Well, they've been kind to us on this indirect proof. They've let us get started with it. They've given us some hints. Remember that an indirect proof is always started by assuming not to the proof statement. So notice the proof statement is Q is perpendicular to FG, so we are assuming that Q is not perpendicular to FG. So if that's the case, then it's possible to draw a perpendicular line. So that's what they started with. They said, okay, let's draw FC so that FC is perpendicular to Q. Now this is going to be a little bit of a stretch for you, but think with me. What they're saying essentially is that this is a right angle. So they're saying this is perpendicular here. Okay, now remember that a perpendicular line is always the shortest distance from a point to a line. So in theory, if this is perpendicular, that means that FC has to be the shortest distance to the line. Okay, messes with your brain, doesn't it? So if this is true, FCG is a right triangle, right? So right triangle. So FC has to be less than FG because the perpendicular segment is always the shortest point, the shortest distance from a point to a line. Now, notice that they did tell us that Q is tangent to circle F. Well, if Q is tangent to circle F at point G, that means this has to be at a right angle. Uh-oh, we have a contradiction, right? Okay, so since Q is a tangent line, it can only intersect circle F at G, which is what I was just showing you right here. All right, and that means that C has to be in the exterior of circle F. So we have no option. That makes FC greater than FG. So here we have our contradiction. Here is a contradiction to this. So the assumption is false, and we can state that Q is in fact perpendicular to FG.